Alright guys, we are moving into Chapter 8. We're going to be looking at covalent bonding, which is a bond between two or more nonmetals. So, two or more nonmetals. So, the last chapter that we looked at was between ionic bonding, and that was a metal and a nonmetal. So, these are going to be a little bit different. We're still going to be doing the same kind of things. We're going to be looking at Lewis structures, naming compounds, things like that, how they actually go together, the geometry. So if you're in geometry, we're going to use a little bit of geometry in here. Not too bad. I don't like geometry. If you hear me yelling at my kids, I apologize. We are at home still on Christmas break, so if I have to pause and yell at them, don't mind me. Hopefully I hit pause and you don't hear me actually yelling at them. But let's go ahead and get started. So molecular compounds are compounds that are held together by a covalent bond. So it's usually, like I said, between two or more nonmetals. So I've given you some examples right here. Those are some examples of covalent bonds. So molecular compounds tend to have lower melting and boiling points in physical science than ionic ones do. In physical science, we showed you a demonstration between salt and sugar. So the chemical formula, salt is NaCl, sugar is C12H22, the one up above, O11. So this one over here is ionic, and this one over here, those are all nonmetals, so this is covalent. And what we did is we put some in a test tube, and we heated them up, and we had like a race. I don't know if any of you guys remember this, to try to figure out which one melted quicker. So the winner, if you don't remember which one melted faster, was this one, sugar. The covalent bonds are weaker. Those are weaker bonds, and they have lower melting and boiling points. So it didn't take it very long. I'm thinking like 18-20 seconds. Salt, on the other hand, because it's ionic, and that bond between these two elements is very strong and held together very tightly, it was hard to break that bond. So I think I stopped trying to melt mine at like a minute, and it wouldn't melt. So, and we just kind of moved on. So covalent bonds, much weaker. Ionic, stronger. That might be a quiz question at some point, so make sure you remember that. Alright, so both elements in the bond are from the right side of the periodic table. Your exception there is hydrogen, because hydrogen is on the left side of the periodic table, but it's not a metal. I think I had you highlight that, kind of box it out, making sure you understand that yes, it's on the left side, but it is not a metal. So just kind of remember that. So instead of giving up or receiving electrons, like in ionic, when you were showing an arrow going from one element, like you would say Na, and then you had Cl, Cl had 7 valence, hopefully you remember this, and you would draw an arrow going from one element to the other. This is going to be a little bit different. This can be shared equally or unequally, but they are sharing electrons. There is not actually a transfer of electrons in this type of bond. If they're shared equally, we're talking about maybe the same type of element. So hydrogen has 1 valence, so not one of those would have a stronger pull than the other, so they would share equally. Now, you could also look at a bond between, like say, ammonia. Ammonia is, I'm going to write the formula up here, but I'm going to write it down below, NH3. So you would have a bond between 3 hydrogens, and I'll show you how I'm getting this in a little bit. So there's a bond there, but the problem here is nitrogen is more electronegative than the hydrogen, so it's going to have a stronger pull on those electrons, so they will not share equally, they will share unequally. And we're going to talk more about that, so don't worry if you didn't understand that. We're going to learn how to draw these structures and everything in this video. Alright, monatomic versus diatomic. You've heard the term monatomic already. Monatomic means 1, diatomic means 2. So monatomic are just single elements. These are noble gases. These are ones that typically don't react with any other elements. And that is, remember, group 18 on your periodic table. Now, you have some diatomic molecules, meaning that when these atoms are found by themselves, they're going to be found bonded with another atom like itself. These are your 7 right here, and you have to memorize them. You have to know that when those are found by themselves, they are diatomic, meaning you're going to see 2 atoms. Now, there's a couple of different ways you can try to remember this. You can look at the periodic table. So if you have a periodic table, pause me, find it, take a look at it. Hydrogen is at the top left. You just got to remember that one. But if you start with nitrogen, and go over to fluorine and go down to iodine, it makes a 7. So there are 7 of them, and they kind of form a 7 except for hydrogen. Now, there's another one that a student memorized, and he came up with the phrase several years ago, and for some reason I remember it. This is the way he remembered it. He made up a phrase. He called it High-Naphtha-Chloride. If you want to use that one, you can. I don't know why it stuck in everybody's head, and that's just kind of how they remembered it. But remember, these are sharing equally. It's just that when they're found by themselves, they'll be with another atom like themselves. Alright, so molecular formulas. Molecular formula is just the chemical formula of a compound. So you're talking like H2O. That's a molecular formula. Or NH3 for ammonia. Those are two very common chemical formulas that you will use. All this really tells us is how many atoms there are, but it doesn't actually tell us how it's put together. So that's what we're going to actually get into, and that's what we call, the next slide, a structural formula. So you're going to be more drawing these types of structures in a little bit. We will get into actually like ball and stick, and this is where we'll get into the geometry of it. But right now, we're just going to focus on this structural formula over here and taking a look at how these structures go together. Alright, so next section, we're just going to go ahead and jump into it. So, like in an ionic bond, electrons are going to share, so each atom will attain a configuration of a noble gas, meaning they want 8. The magic number is still 8 that they want to have around them. There are going to be exceptions. So, we'll get into those. We may see a couple of them in these, but don't worry about it right now. Just know that there are going to be some atoms that are going to have either more or less than 8, and they're still going to be happy that way. We'll talk about that, though. Remember, these bonds are between elements in groups 14, 15, 16, and 17. So what I'm going to do is show you a different way than the way you learned in physical science to do this. I've struggled whether to kind of teach it this way in physical science, but I just don't think it would work. But I think you guys are going to get it this year, so let's just kind of jump right into it. So to do this, what you have to do, I'm going to do this in red. You're going to sum, if I give you a chemical formula, say I give you NH3. And I want you to draw the structural formula of that. Your first step is going to be to sum the valence electrons from all the atoms. So if you look at the periodic table, nitrogen has, can't draw very well. Start over. Okay, nitrogen has 5 valence electrons. And then you have 3 hydrogen atoms in that formula. If you look at the periodic table, they each have 1 valence. So I've got to add that up. So that means my structure is going to have 8 electrons somewhere in it. Your next step is to write the symbols for the atoms. Show which atoms are attached to which and connect them with just a single bond. So just a dash. That dash, you have to remember, it always represents 2 electrons. So nitrogen is going to be my central atom in this. Hydrogen will never be a central atom. Just remember that. So then I'm going to show dashes because I've got 3 hydrogens attached to this somehow. So if I count this, remember each dash is 2 electrons. So I've got 2 on one line, I've got 2 electrons there, 2 there, and 2 there. So that is 2, 4, 6. I've got 2 more electrons left over. So then I'm going to put them there. I'm going to tell you that in the next couple of steps, but right now let's just focus on that. So the next rule, you didn't have this problem because it says to complete the octet around all the atoms bonded to the central atom. Well, you had this structure. Instead of putting the ones on nitrogen, I would have started with the hydrogen, but hydrogen can only have 2 electrons, so no more electrons can go around those hydrogen atoms. I'm going to do another example in a minute to kind of go through step 3, so we're going to come back to that one. So again, I already did this, but if this was my structure, it says to place any leftover electrons on the central atom. So remember, I counted around this, I had 6. But in step 1, if you go back, there are 8 electrons. That is why I put those dots there. So if there are not enough electrons to give the central atom an octet, you've got to try multiple bonds. So I am going to try to fit this somewhere. I'm going to do it in blue, but I'm going to do it above step 5. So we're going to look at, say I give you this structure, CO2. Now CO2, if I go through all the steps, go back to step 1 and take a look at it. It says to sum the valence electrons. So if I sum the valence electrons, carbon has 4. There's 2 atoms of oxygen. Each of them have 6 valence. So I am looking at 16 electrons total around this atom. So if I start out, step 2 says to write the symbols and then attach them with a single bond. So I would start by saying carbon, oxygen, and oxygen. So there I've done step 2. Now go to step 3 and it says complete the octets around all the atoms bonded to the central atom. So not the central atom yet, just the ones connected to it. So that would be the 2 oxygen atoms. So right now that dash is representing 2 electrons kind of around it. So what I would say is I've got 4 electrons total right now. So I'm going to say there's 5 and 6, 7 and 8, 9 and 10. So it can have, remember, it can have 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. And I'm at 10 electrons right now. So it would be 11, 12, 13, 14, 15, 16. So there is a structure drawn with 16 electrons. But if we look at step 5, it says if there are not enough electrons to give the central atom an octet, then we have to try multiple bonds. So if you look at that carbon atom, it has 2 dashes around it. That represents 4 electrons. But it really needs to have 8. So what you're going to have to do is take that pair, cross it out, and make a double bond. So that will make 6 around carbon. You're going to have to do that same thing over here. So this pair of electrons is going to become a bond between. So then you get a structure. I'm going to kind of redraw it in red down here. You're going to have this structure. So each of the oxygen only has 4 unshared pairs, meaning not in a bond. And now your central atom does have that octet. So that is what we're going to practice with the next couple of examples. So I'm going to go ahead and keep going with this. So keep those rules handy. We've done this one, but let's just go ahead and kind of do it together. So your first step is to get the valence electrons. So nitrogen has 5. There are 3 hydrogen. They each have 1. So that means I'm looking at 8 electrons around this structure. So remember, you just connect them first. And then with those lines, I'm dealing with 6 electrons right now. And I need 8 over here. So no more can go on the hydrogen. So my other 2 electrons are just going to go on that central atom. And that's how you draw that one. The next one, you've got CH4. So carbon has 4 valence. Hydrogen, there are 4 of them. Each one of them has 1 valence. So you're looking at 8 electrons on this one. So again, connect them with a single dash at first. Well, if you take a look at this one, each line again represents 2 valence or 2 electrons. So you've got 2, 4, 6, 8. You're done with that structure. There's nothing else you need to do to it. So let's move to the next one. Phosphorus, there's 1 of them, has 5 valence. There are 3 chlorine, so we're going to have to multiply it by its number of valence, which is 7. So I'm looking at 21 plus 5, I'm looking at 26 electrons in this structure. So let's start. First of all, you need to look at which one. Usually it's going to be your first atom listed, that's your central atom. But it's going to be, if you want to jot this down, it's going to be the least electronegative one. Least electronegative one is your central atom. Very sloppy writing, but I'm sure you can kind of read that. So that means phosphorus. If you look at, you've got to go back to your trends on which one is more electronegative, what the trends are. So electronegativity increases left to right, and it decreases as you go down the periodic table. That makes phosphorus my central atom for this. There's 3 chlorine, so I'm looking at this as my starting structure. I've got 26 electrons I've got to put around here. Right now I've got 2, 4, 6 with the lines. So I'm just going to go ahead and start going around my outer elements. So this would make 8. That would be 10, 12, 14, 16, 18, 20, 22, 24, and I've got 2 electrons left over. There's nowhere else to go but right there on that central atom. Phosphorus has 8 electrons around it, so that structure should be correct. Let's move on to your next example. If you need to rewind this and get it, if I'm going too fast, go ahead and rewind it and listen to that example again. Alright, CH2Cl2. So 1 carbon, 4 valence. 2 hydrogen would be 2 times 1 valence, plus 2 chlorine times 7 valence. So added that up, that would be 20 electrons that I'm dealing with for this one. So I'm going to start by connecting them. So typically carbon is going to be your central atom. So I'm going to draw that carbon, and then I know I've got 2 hydrogen somewhere, and then I've got 2 chlorine. So right now I've got 2, 4, 6, 8 electrons. Remember, nothing else can go on hydrogen. It can only have 2 electrons total. So I'm looking at the chlorine atoms getting the rest of the electrons. So this would be 10, 12, 14, 16, 18, and there is 20. So hopefully you're catching on to this. I think this is easier. I just don't know if they'd be able to handle this in physical science. So I'm hoping that you're catching on to this. One last example before we start getting into some polyatomic ions and drawing those structures. I've got hydrogen, which is 1 valence, carbon, which is 4, and nitrogen, which is 5. So in the structure, I'm looking at 10 electrons. So remember, your least electronegative atom is your central atom, so don't include hydrogen, so it's either carbon or nitrogen. Again, carbon is the less electronegative, so that's going to be my central atom. So I'm going to connect these like this. That takes care of 4 electrons. So I'm going to say 4, 6, 8, and 10. Hopefully you can kind of look at this and see the problem, because you're not done with the structure. The problem is you've got a carbon atom that only has 4 electrons around it. So you're going to have to take these electrons and put them down here as a bond to get 6, and then you're also going to have to do that for this one. So I'm going to redraw this structure in red. You would have to have a bond, a triple bond, and you would only have 1 pair. That pair right there is what's left over on that bond. So that the bottom in red is the way that you should draw that structure. Alright, so we're going to go ahead and move into some ions. There's not much difference about this. The difference is in these is what you've got to look at is the fact that there's a charge on this. And that charge means it's gaining electrons. It's going to be negative, so it means it's gaining electrons. So the only difference here is how you're figuring out your valence electrons. So you have 1 bromine atom that has 7 valence. You have 3 oxygen, which has 6. But then you've also got that 1 minus charge. So that 1 minus charge means that it has gained 1 electron. So that's got to go into the calculation. So you're looking at 18 plus 7 plus 1. So you are looking at 26 electrons in your structure. So bromine on this one, I'm not sure which one is least electronegative. I think bromine is. So bromine is your central atom, but there could be exceptions to this. So the structure is going to start out the same. You start out by placing your electrons around there. So right now you've got 2, 4, 6 electrons. So this would be 8, 10, 12, 14, 16, 18, 20, 20, 22, 24, and then 26 electrons. It would look like that. Now, the difference with an ion, the way that we write this is we do have to put it in brackets like this, and then you put the charge on the outside. So the difference is right here in blue. You've got to add how many electrons for the charge. It's got to match the charge. And then you've got to put these brackets and put the charge. Really, the same kind of thing is going on. You've got to make sure that you get the structure drawn correctly. Okay, so I knew I wouldn't be able to make it through that without having to yell at kids. Hopefully you didn't hear that. Alright, sulfate, SO4 2-. So sulfur has 6 valence electrons. I've got to add that to the fact that I have 4 oxygen. They each have 6 valence electrons. And then I have a 2- charge, meaning it has gained 2 electrons. So I'm looking at 24 plus 6. I'm looking at 32 electrons for this structure. So again, typically the first one listed is going to be your central atom, so that means sulfur. I've got it attached to 4 oxygen, so I've got that right there. That takes care of 8 electrons, and I've got to get to 32, so I've got to start with my outer ones. So this would be 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. It works out perfect. So there's my 32 electrons. I've got an ion going on, so I've got to draw the bracket. And I kind of messed up my bracket there. And then I've also got to write the charge out here. It is a 2- charge. So there is the sulfate ion. Alright, let's try carbonate. Alright, carbonate. You've got carbon, which has 4 valence electrons. You've got 3 oxygen, which each have 6. And then you've got a 2- charge. It's gained 2 electrons. So that would be 24 electrons. So again, I've got carbon attached to 3 oxygen atoms. So that takes care of 6 electrons. So there's 8, 10, 12, 14, 16, 18, 20, 22, and there's my 24. Again, this is an ion, so we draw it in a bracket and put the charge outside. Let's move to the next one. I believe this is chlorate. I'm not sure if I had that right. I think it's chlorate. Anyway, there's 1 chlorine, which has 7 valence. And there's 2 oxygen, which has 6 valence, and it has a 1- charge, meaning it's gained an electron. So I believe I am looking at 20 electrons here. So chlorine central atom, 2 oxygen attached, but that only takes care of 4 electrons. So I'm looking at, there's 6, 8, 10, 12, 14, 16, and I've got 4 more electrons. I'm done placing them and getting my octet on the outer one, so I've got to go to the central atom here. There would be 18, and there's 20. and chlorine has an octet around it, so that should be, right now, that is the correct drawing. We are going to move into something different in the next video, but we're going to go ahead and just keep it at that. This is an ion, so I draw the bracket and I put the charge. Alright, one last structure to draw. We've got the phosphate ion. I'm going to do this one in blue. Try to red. Phosphorus has 5 valence, 4 oxygen, each having 6 valence. 3 minus charge means it's gained 3 electrons. So I am dealing with 32 electrons in this structure. So I've got phosphorus atom in the center that is attached to 4 oxygens. That only satisfies 8 electrons, so I'm going to go ahead and go around and say 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32 electrons. Again, this is an ion, and the charge goes out there. So we are going to practice with these more. There's one last slide in this video, and it's just dealing with the fact that you've got polyatomic ions. If you've got a compound, say like Na3PO4, you have 2 types of bonds going on in this. You've got a bond right here between the phosphorus and the oxygen, which is covalent because you're looking at 2 nonmetals. But overall, you have a bond between a cation and an anion, which is ionic. So you've just got to understand that that has both types of bonds. So I just kind of threw that in the end for this one. So we're going to go ahead and stop the video there. We're going to practice with more of this, and then we're going to move on and kind of build on this on the next video.